Hey everyone, so today we're going to solve Cambridge International's A-Level Peer 1 paper of May 2025. I'm going to do variant number 2 first. Okay. So let's start with question 1. So question 1 is on chapter 2. We're given a function and we need to describe fully a sequence of two transformations which transforms the graph of y equals f of x to the graph of y equals g of x. Now let's see what's happening from f to g. If you look at, let's look at the original graph of f. Okay. That point over there is 0, 6, so it's a y-intercept, obviously. Then let's look at the new graph. We have 0, negative 2. Let's also look at this point over there. That is 3, 3. And this one down here is 3, negative 8. Now, if we can figure out what happened to these points, we will know which two transformations we have. Now, if you look at specifically this piece over there and that piece over there, the x values stay the same. We have 0, 0 or 3, 3. So something only happened to y and it looks kind of stretched out. So I think there's a vertical stretch. Now, how can we figure out by which factor? In the original function, from the one point to the next point over there, there's 3 units. What about at the new function? There's 1, 2, 3, 4, 5, 6 units. How do we get from 3 to 6? You need to multiply by 2. So there's a stretch factor of 2 vertically. We can also check this piece over there. Obviously from there to there is 1 unit. And on the new graph, there to there is 2 units. So that corresponds with what we had over here. 1 times 2 is 2. But let's look at the point 0, 6. If I say 0, 6 times 2, I'll get 0, 12. And that's definitely not the new point over there. How can we get from 0, 12 to 0, negative 2? You can do 0, 12 minus 14 to give you 0, negative 2. Let's check if that works with another point, 3, 3. If I take 3 and 3 times 2, I'll get 3, 6. And if I say 3, 6 minus 14, I'll get 3, negative 8. So we have our second point over there. Now, how do we write this down? The minus 14 on the y means it moved 14 down, but we're not allowed to say that. We can say, well, let's get the order right. First, there was a vertical stretch by factor 2. That happened first. Then there was a translation by vector 0, negative 14. That happened next. This 0, negative 14, in the first row, you write whatever happened to x. We didn't move x anyway, so we write a 0 there. In the second row, you write what happened to y, and y moved 14 down, so I write a negative 14. Okay, let's do question 2. Question 2 is on chapter 1 in your book. We need to find the coordinates of the points of intersection of the curve and the line with equations. That first one and then the second one. The first one appears to be quadratic, kind of, and the second one is linear. One important thing over here is they say points. So our answer in the end needs to be 2 points. Now, let's look how we can solve this. We need to obviously solve this simultaneously. Okay. It's always best to substitute the linear equation into the quadratic one. But what's the easiest way to do that? Now, there's a few ways. You could either write x on its own on the left and substitute for x, or you can write y on the left and whatever you get, substitute in for y. But I noticed that there's kind of a shorter trick over here. We can take the second one and you can say, oh, that m over there from the second one, you can say 2x is equals to negative y minus 4. I take the y and the 4 to the other side. Now in equation 1, we have a 2x over there, so I can simply plug in this whole negative y minus 4 into there. So what do I mean by that? Let me call this 3. We can substitute equation 3 into equation 1. So we can have 2, so we have 2xy plus 5y squared is 24. But what is 2x? It is negative y minus 4 times y over there, plus 5y squared is equals to 24. Okay, so I have y minus 4 plus 5y squared equals 24. Let's take that y into the bracket. We'll have minus y squared minus 4y plus 5y squared is 24. So now I have 5y squared minus y squared is 4y squared minus 4y. And let's bring the 24 to the left. Becomes negative 24. Now we need to factorize this. If you struggle with factorization, I made a video on that. I'll put the link in the description. The first thing you always need to do is check, is there a common factor? Yes, we can take out a 4. What's negative 24 divided by 4? Negative 6. Okay, that 4 you can simply divide away. Okay, all we have left is to factorize this quadratic. That will become y and y. The factors of 6 are 6 and 1, or 3 and 2. We need 3 and 2. So I'm going to write 3, 2, and it's going to be minus 3 plus 2. So y equals 3 for y equals -2. Okay. But remember, we need to solve for x2. As in, we need to also solve for x. And remember, this was the equation for x. Okay. Let's quickly put that here. Now 2x was -y minus 4. So 2x, if I substitute y is equals to 3 first, I'll have -3 minus 4. X will be then -7 divided by 2. What about when y is -2? I'll have 2x is -2 minus 4. That's 2 minus 4, which is -2. If I divide by 2, x is -1. Let's write down. I kind of messed up with space here a bit. I feel like they should have given you another page to write on. But let's just write down our final 2 points. X is -7 and 2. What was y? It was 3. And when x is -1, y was -2. Okay, let's move on to question 3. Question 3 says the coefficient of x to the power of 7 in the expansion of that bracket is 1280. And we need to find the value of the constant p. Now, what deals with the coefficient of terms in expansions? That's the binomial theorem. And that is in chapter 6. Now, the binomial theorem is luckily given in your formula list. It's over here. Now, we need the general form of each term. You can see I've kind of written it over here. It's always n, choose r, a, n minus r, b to the r. By the way, this is not a vector. It means n choose r. Here's the general formula, but you can also use your calculator. I'll show you how to do that just now. Okay, let's write down that general form. Okay. Now, this one is tricky because both terms in the bracket have x's. You'll know what I mean if you've done maybe the exercises in the book or something. But I can show you a trick because it's only 4 marks. You don't want to be here forever. So let's write that like this. Now inside the bracket, let me factor out an x. Like that. Okay, so I took an x out. If you take that back in, you'll have px squared 4 over px. Okay, now to work with this, you need to know your index laws from IGCSE. I've kind of put a little summary over here. We need to use rule 4 now. That can become x to the 5 and then px 4 over p power of 5. Now this one's a bit easier to work with because now there's only an x there, so we can easily spot the term that we need. Okay, 4 over p is just a number. Remember, p is a constant. Now what would this look like if you were to expand it? You'll have x to the power of 5 on the outside, and to expand the big bracket you'll have, say, something x to the power of 5 plus something x to the power of 4, and so on. Okay, the pattern will go on like that. Now if you multiply x to the power of 5 with x to the 2, that's going to give you the term with x to the 7, which is the one they give us. They give us the coefficient. Now we need to use that coefficient to find p in the end. Okay, so what happens if in our general form over here I let a be 4 over p and I let b be e to the x? You can also do it the other way around, but if you do it this way around, what will happen? You'll have n choose r 4 over p to the power of n minus r, and then px to the power of r. Now we want x to the 2 because that's going to give you x to the 7 once it's multiplied. Okay, now how can I get x to the power of 2 over here? Only if I make r over there 2. Okay, by the way, what is n? N is always the power of the bracket. You can see in your formula sheet that n is the same every term. So n is 5 in our case, and we just figured out our r is 2. I can write 4 over p. Our n minus r will be 5 minus 2, which is 3. Okay, now keep on using your index laws. Okay, let's figure out what's 5 to the power of, no, sorry, 5 choose 2. On your Casio calculator, you can press 5, then shift the division symbol 2. So you have 5c2, and it will tell you it's 10. By the way, it doesn't mean 5 times 2 is 10. This is using this formula over here to find 10. Okay, now take in the 3 using your index law, that's specifically rule 5 over here. You'll have 4 cubed over p cubed. You can use another index law over there. It will be p squared x squared. Okay, what's 10 times 4 to the power of 3? That is 640. We can write p squared over p cubed x squared. That will become 1 over p. So we have 640 over p is equals to x squared. Now remember, this is going to still multiply with x to the 5, so it will technically become 640 over px to the 7. Okay, the important thing is we want to solve for p, but we know what this coefficient should be. They said it is 1280, so you can say 640 over p is 1280. Okay, you can flip both sides. E will end up being 640 over 1280, which is just equal to half if you put it in your calculator. So there you have it. P is equals to half. Now you can decide what is easier, this way or over here. I've kind of given you the more traditional way, where you let A be the first term in the bracket and be the second term. This one is just a bit more complicated because you'll have so many power rules that you'll have to deal with. Just look at all of this. It's a bit crazy. And then if you do it this way, your R will end up being 3. Okay, but in the end, look, you still get the same thing. P is equals to half. You can also check the mark scheme. So it's up to you. You can take a screenshot of this if you want. But I would say use this way. It's a bit easier. Okay, let's look at question 4, which is on chapter 8 in your book, specifically connected rates of change. So they say a point P is moving along a curve in such a way that the x coordinate of P is increasing at a constant rate 5 units per second. So that has to do with time and an x coordinate. Okay, so they give us dx dt, which is 5. And they want us to find the rate at which the y coordinate of P is changing when x is equals to 9. So they want us to find the rate dy dt, okay, when x is equals to 9. But the problem is we don't have a equation that's in terms of y and t. We only have one that's in terms of y and x, but we can use the chain rule to change around. We have the chain rule dy dt is equals to dy dx times dx dt. And we have dx dt. We can easily find dy dx because we have y in terms of x. So that can help us find dy dt when x is equals to 9. So let's first find dy dx. Okay, so we need to differentiate y over there. I can bring down the 3 over 2 times a times x to the power of 3 over 2 minus 1 minus 12. Okay, because we have x to the power of 0, so it just becomes minus 12 because x to the power of 0 is 1. Okay, let's simplify this. It would be 3a over 2, and 3 over 2 minus 1 is x to the power of half. Okay, now let's find this when x is equals to 9, because we want dy dt when x is equals to 9. Okay, so I'll just substitute 9 over there. 9 to the power of half is the square root of 9, so we'll just end up having 9a over 2, because we'll have 3 times 3a over 2 minus 12. Okay, now let's use the chain rule over there. We'll have dy dt x is equals to 9 is the 9a over 2 minus 12 times the x dt, which is 5, because it's constant, so it's gonna be 5 even when x is equals to 9. So I'm gonna say it's 5. Okay, you can multiply the 5 in, we'll have 45a over 2 60. Okay, question B is more based on chapter 7. given that the curve has a minimum point when x is equals to 1 over 4, find the value of a. Okay, when does a point have a minimum curve? When the derivative of that curve is equals to 0, or even if it has a maximum point, a minimum or maximum. Let's take our dy dx, which we already found over there, and equate it to 0, which is 3a. Oh no, let me use the simplified one. 9a 2 minus 12 equated to no, wait, I used the wrong one over there. No, that's when x is equals to 9. It's not what x is now. Let me just use the general form. 3a over 2x to the half minus 12. Remember, this occurs when x is equals to 1 over 4. So let me sub that in. 2 1 over 4 to the power of half minus 12. Okay, now we only have an equation in terms of a, so we can easily solve for a. The square root, or the power of half, of 1 over 4 is just 1 over 2. Okay, let me continue there. So I have 3a over 4 minus 12 is 0. And if I take the 12 to the other side, you can end up solving that. You'll get a is equals to 16. Okay, question 5. Question 5 is obviously trigonometry, which is chapter 5 in Pure 1. They give us the equation of a course curve that's been transformed a bit, and we're working in radians because we're between 0 and 2 pi for x. Now we need to state the greatest and least possible values of y. Now, how would I do this? Like, if you think of the original course curve, what happened to it over here? It's been multiplied by 4 in the y and multiplied by 2 in the x, and we've added 3 onto it. What do all those numbers do? All those numbers do to the original curve? The 2x just changes the period, as in how regularly the curve will repeat. So between 0 and 2 pi, that 2x will cause that the course curve is going to repeat twice. Okay, so that doesn't really change the least possible values and the greatest possible values of y. So we mostly need to look at the 4 because that changes the y, and the 3. Now the original course curve, what is the least and greatest possible values of it? If you look over here, okay, this graph of mine is in degrees, but it usually goes between 1 for y, and so it usually goes between 1 over there and -1. Now we just need to adjust that. So let's write, well, cos 2x will still be between -1 and 1 because the 2x doesn't change the y. Now we will multiply it by 4, so we'll have 4 cos 2x. So I need to multiply by 4 minus 1 and 1, so I'll have minus 4 cos 2x less than or equal to 4. So currently for cos 2x, the least possible value is -4 for y. The greatest possible value is 4. And what about if we add the 3? That moves it up. I add 3 out. I'll end up with 7, and -4 plus 3 is -1. 4 cos 2x plus 3 is y. So now y is between -1 and 7. Okay. Question 5b. Now we need to sketch the curve. I kind of do not like how much space they've given you here to draw this curve. You'll see why now at C. Well, let's try to draw this curve and think about how could you do that in an exam. I would start with dividing the y-axis up because they didn't do that for you. So the greatest possible value for y is 7 and the least is -1. So let me divide the y-axis over there into maybe until 8. So what am I gonna do? I'm gonna count in 2. So yes, 2. So this you'll maybe do in pencil. Let's say 2, 4. This is gonna help us draw 2, 4. Let's say that's 6, and then 8. So we'll have 2, 4, 6, 8. Okay, we need to keep the same grid lines over there. The negative, so that's -2. So -1 is between 0 and -2 over there. Okay. What is this over there? That is pi over 2 divided by 2, which is pi over 4. And the next would be that's 135 degrees. What is that? It's 180. To get from 180 divided by 135, so that's 4 pi over 3. That's pi. Next, that is 225 degrees over there. Sorry, I think in terms of degrees a lot. So that's 5 pi over 4. 3 pi over 2 over there, so that's 270. And that is 315 degrees. Let me see. To get from, so that's 7 pi over 4. Okay. All right. Now we need to plot this. I would suggest using a calculator because in the next question you need to draw a pretty accurate straight line through this course graph to tell them how many solutions is there when that straight line in this course graph is touching. So let's first make sure if there's a R on your calculator, that means your calculator is in radians. Oh, I only realized now you can't see the calculator. Let me move it to there. So if there's an R on your calculator, it's in radians. Otherwise, you need to press Shift, Setup, and press 4 to go into radians. Now we're going to go to press mode. We're gonna go to the table mode. I'm gonna put in our function, our course graph for cos 2x plus 3. The calculator is going to ask, where do you want to start? At 0 radians, end at 2 pi radians, step. The steps I've made on my x-axis is in pi over 4 that we're counting in. Let's put pi over 4. Okay, now what is this giving you? It's giving you the y coordinates of all these x labels down here. Okay, this table mode doesn't display the pi symbol, so for example that 0, okay, that's obviously where the curve cuts the y-axis, but that's 0.7853, that is pi divided by 4. So when we have pi over 4 for x, the curve is at 3. 3 is somewhere there between 2 and 4. The next one is for pi over 2, it's at -1, so somewhere down there. Then we have 3. Then we have 7 when it's equals to pi. So up there you can already see the shape of the curve. Then 3 again. Now it's just repeating the pattern. And then I'm guessing it's gonna be at -1. And then again probably 3, am I right? Let's see, yeah, 3 and then 7. Okay, which makes sense because our maximum value is 7. Let's just write a 7 there for them, and the minimum value is a -1. Write that in. Okay, now draw the course curve. I'm not the best drawer here on the computer. Here we go. So there's your curve. And then it's pretty accurate. Again, I just wish they gave you some more space. Now in C, like I said before, they want you to find the number of solutions of that equation. That equation is just the course curve from question 5a, you can see over there, and it's been equated to another curve which is just a straight line. Now we can see the number of solutions. This is just 1 mark, so let's try to be quick. It's gonna, that's a straight line, y is equals to 2x minus 1, which means gonna cut the y-axis at -1, but we need another point to draw it. Let's get the x-intercept. 0 is equals to 2x minus 1, so 2x is equals to 1, so x is equals to half, which is 0.5. Now where is 0.5 on our grid over there? Let's go back to normal mode on the calculator. Pi over 4, what is that as a decimal? That's 0.7, and that straight line cuts at 0.5, so it's gonna be somewhere over there. Okay, that doesn't have to be perfect. In fact, I think you should do this in pencil and then rub out, like erase this line that you've drawn on here, because for question B you're strictly supposed to draw a course graph, not the straight line. But this helps you to see there's gonna be how many solutions when, remember when you equate two graphs, it's where they intersect each other. We have 1, 2, 3 points. So there will be 3 solutions. Okay. Question 6 says the diagram shows the curve with equation and a line. The line and the curve intersect at point P, which has y coordinate 3. And we need to find the area of the shaded region. Okay, let's fill in that mention of y is equals to 3. So P is at y equals to 3. Okay, at which x coordinate is it? Well, we can easily find that. In fact, we do need it. If y is equals to 3, we'll have 6 minus 3x. So 3 minus 6 is x. So negative 3. So that seems to be x is equals to 1 over there. Okay. Is that correct? Yes, it's correct. Okay. Seems a bit off, but I guess it's not drawn to scale. Okay. We need the area of the shaded region. How can we find that area? Areas under graphs has to do with integrals, which is chapter 9. Okay. We can find the area under these curves, no problem. But the thing is, we can kind of need the area that's under both of them at the same time. Now, we can use a definite integral to find this first area below the curve of this curve. I don't know why they didn't give them names. That one, we can find that area underneath it. Let me call it area 1 using a definite integral from x is equals to 0 to x is equals to 1. What about this other area that I'm putting in yellow? Let's call it area 2. That's simply a triangle. What is the height of that triangle? It is 3. Okay. And what is its base? Well, we need that point over there. That's the x-intercept of the straight line. Let's quickly get it. Yeah, that's right. So x is equals to 2. Okay. X is equals to 2 over there. So how long is the base from 1 to 2? It's just 1. So we can use our normal formula, half base times height for that piece. Let's find area 1 over there. So we need the definite integral from 0 to 1 of 9 over 5x plus 4 power of half dx. Okay. Coefficients can go outside. They are just in the way. Okay. That power I'm gonna write as a negative. Okay. Now there's a formula in chapter 9 to solve an integral that looks like this. It will give you 1 over 5 times negative half plus 1, which is just half. So I'm just gonna write that space, and then 5 to the x, 5 times x plus 4 to the power of also negative half plus 1, which is just half again. And we want to evaluate this from 0 to 1. Okay, we evaluate the 1 minus the 0. You'll end up getting 2 over, okay, that 5 times half will become 5 over 2. So it's 1 over 5 over 2, which is 2 over 5. We'll have, now I'm substituting the 1 in there. I'll have 5 times 1 plus 4, which is 9. 9 to the half. Okay, and we subtract the 2 over 5 and we substitute the 0. It will be 0 plus 4 to the half. Okay, we're almost there. 9 to the half is times 3. That's basically the square root of 4 times 2. Okay, if you put that in your calculator, you'll end up getting 18 over 5. Remember, we want the area of the whole region. I need to add the triangle. Okay, half times base is 1 times 3. That will end up being 3 over 2. So the total area is 18 over 5 plus 3 over 2. That will give you 51 over 10. Okay, question 7. Question 7 is chapter 5. It's a trig identity that we need to prove. Let's start. What's going on with my pen? Let's start with the left side. Okay, you always check, where do you want to end up? You want to end up with something that has sine and cosine in it. Currently we have tan. How does tan connect to sine and cosine? Well, we know tan is equals to sin over cos. So let's substitute that in. Sin over cos plus 7 all divided by tan squared. That's still sine squared over cos squared. Okay, it's 3. Okay, let's get common denominators at the top and at the bottom. We'll have sin plus 7 cos all over keep a bracket there, get confused. At the bottom, common denominator is cos squared, have sine squared, it's 3 cos squared. Okay, now you need to use this rule. If you have a over b divided by x over y, become a over b times y over x. Division becomes multiplication, and you flip the bottom one. Okay, we'll end up having that multiplying with cos squared over all the numerator. Okay, a cos can cancel. We'll have one cos left over there. Okay, then we'll have left basically cos squared times that on the left. Then remember we cancelled that cos, so over there we just have that. Okay, what can we do? Oh no, that's not a cos squared because I cancelled one. Let me just write that over so that this becomes cos. Now multiply that cos in sin cos plus 7 cos. All right, we already have the top over there. What about the bottom? They only have cos squared. How can sine squared be changed to cos squared? We know sin squared plus cos squared is 1. Sine squared is 1 minus cos squared. So I can write 1 minus cos squared over there, minus 3 cos squared, and then top stays the same because that's what we want. And at the bottom you have 1 minus 1 cos squared minus 3 cos squared, which is minus 4 cos squared. So 1 minus 4 cos squared. And there we have it. Okay, moving on. B, hence solve the equation. Okay, that on the left is the exact same expression they had over here on the right, which is equals to that. Let's rather use that more simplified version. So tan alpha plus 7, or not alpha, theta, tan squared minus 3 is equals to 5 tan theta. Okay, now you want to end up with one trigonometric function on the left is equals to a number for you to be able to solve this equation. Let's cross multiply, as in that goes there and that goes there. What will we end up with? We'll have 10 times 10 plus 7 is to 5 times 10 squared minus 3. Take the 10 in, I'll have 10 squared plus 7 10, 5 10 squared minus 15. That's a 3 over there. Okay, so let's bring everything to the left. 10 squared minus 5 10 squared plus 7 10 plus 15 is equals to 0. We'll have minus 4 10 squared 7 10 plus 15. Now I don't like working with a negative in front there, so I multiply by a negative 1. Okay, changes the signs of terms. Okay, cool. Now This is a hidden quadratic. Let's let x be tan. So I'll have 4x squared minus 7x minus 50. Now you can factorize that. I have a link in the description for how to factorize 4x plus 5x minus 3. Then we'll have x is equals to negative 5 over 4, or x is equals to 3. But we're not solving for x, we're solving for tan. So tan is equals to that because x is tan, or equals to that. Okay, we're almost there. Now, how do you solve trigonometric equations? People prefer doing it different ways, but the way I do it is I do not enter the negative into the calculator. Let's first see, we are in degrees. Make sure calculator is in degrees, if there's a D on it. Okay, now let me do the first equation. Shift tan, shift, and we'll have tan inverse 5 over 4. I don't enter the negative. I get what I call a reference angle, which is 51.3 degrees. Okay. Or the other one, let's also do it. I'm also, okay, there, that's equals to a positive one. It's less complicated. Theta would be equal to what over there? 71.6. Okay. Perfect. Now, okay, that's already one solution. The other solution, let's complete this over here. I don't enter the negative into the calculator, but I use the cos diagram. That is theta, that's 180, minus theta, that's 180, plus theta, that's 360, minus theta. Now tan is negative. Where is tan negative? Either in the second or fourth quadrants. But for tan, you only need to worry about one of these quadrants. You get the same answer because tan repeats every 180 degrees, so it's kind of symmetric. So all we need to do is our theta for when tan is negative 5 over 4 would be 180 degrees minus 51.3, which gives you 128.7. So our two solutions is that one or that one. Okay, question 8. Question 8 is kind of a nice combination of chapters 3 and 4. So it's all about circles, sectors, segments. Yeah. Question A says, well, we start with the diagram shows a circle and a line y equals to -2. The line intersects the circles at the points A and B, and the center of the circle is C. Okay, that's important. Let's also fill in that y is equals to -2. And we need to find the coordinates of A, B, and C, which is the easiest one to start with. We could find the center of the circle C. Now, you could either do it via completing the square, or you could use a formula, but I don't like using the formula because then it's another thing you need to remember. rather just complete the square, bring the x's together and the y's together, and then take the constant to the other side. If you complete the square for this, you'll have x minus 7 squared minus 49, and for y you'll have y plus 4 squared minus 16. Okay, let's finish it up by taking all the numbers to the right. Minus 36 plus 49 plus 16. We can already see the center, but I'm doing this because we're gonna need the right hand side later on. We're gonna need the radius. Minus 36 plus 49 plus 16 is 29. Okay, so the center C is 7, negative 4. Okay, you have to flip the signs of those numbers. Okay, now what about A and B? A and B both lie on that line y equals negative 2. So if you simply substitute that line into the equation, you will be able to find those 2 points. Okay, let's substitute it into this new equation we have. We have x minus 7 squared, so I'm substituting y is equals to negative 2, and then instead of y I put the negative 2. Okay, now we have that bracket on the, this one over there, that's simply a number. That's 4 minus 2 squared, just 2 squared, but just 4. And now we get a bit lucky because 29 minus 4 is 25. And if I take the square root both sides, remember you need plus or minus on the right, we can easily find the square root of 25 is just 5. So I'll have x minus 7 is either positive 5 or x minus 7 is negative 5. We'll end up with x is equals to 12, or x is equals to minus 5 plus 7, which is 2. What does that mean? Okay, remember A and B, on that line y is a negative 2. Now which one is A and which one is B in terms of x? Obviously the far left one should be the smallest number, 2, and this should be 12. So that tells you A is 2, a negative 2, and B is 12, a negative 2. Okay. This question 8 has a part B and a part C. Let's do part B. Find the angle ACB in radians. Give your answer correct to 3 significant figures. Okay. I'm gonna bring a copy of that diagram down here. You could obviously write on the diagram in the actual exam. I'm just gonna do that over here to simplify things. Okay, which angle do they want? ACB. So you need to kind of make up your own triangle. AC. Oh, it's not making a straight line today. A to C. Can you wake up, laptop? Ish. Okay, let me rather use there. Okay. Let's just, I've kind of covered up C. Let's remember that C. What is C, by the way? You already have it. Remember, it is 7, -4. Currently, we're looking for ACB, that one over there, that angle. Okay. Now, how can we do that? Your mind might go to arc length or the area of a sector, but we're not given any arc length or the area of a sector. So we need to think back to IGCSE. Okay. Now there's a few ways you could do this. I think you could use the sine rule or the cosine rule, or you could use probably even the area rule, but I'm gonna use trigonometric ratios, as in SOHCAHTOA. Now remember, this is a circle, and if you think back to circle theorems, the line that goes from there to there meets the chord AB at 90 degrees, and it splits it in half. Now, how far is it from A to B? It's all on the same line, y is equals to -2. And how far is it from 2 to 12? 10. That means this should be 5, and that should be 5. Okay. Now, that means we have two right angle triangles, and we can find that angle over there, which is in any way just going to be equal to that one over there. Okay, so far we only have the side 5, but how far is it here from C to B and from C to A? They are both radii, and remember we had r squared over there is 29. That means that the radius is the square root of 29. Okay, so I have the square root of 29 there, and also there. Okay, what do we have? Think of this angle. You have the opposite side and the hypotenuse quickly available. Now, what deals with opposite and hypotenuse? That is the sine ratio. So sine, let's call it, that's technically angle ACB divided by 2, because I'm only getting half of it using this ratio. So an opposite is 5 and hypotenuse is square root 29. Okay, if I take inverse sine on my calculator, that should be in radians for this question. Let's open up the calculator. Am I in radians? No, I need to switch over. Okay, sine inverse of that is 1.19. Let's go with that. So to get the full ACB, I have over 2 is that. To get the full one, I need to multiply by 2. What's 1.19 multiplied by 2? That is 2.38. Perfect. Okay. And that's in radians. Okay. And we have our 3 significant figures. Okay. Next up, the chord AB divides the circle into 2 segments. Find the area of the larger segment. Now it's important to not get confused between a sector and a segment. let's kind of make a simplified version of our triangle and circle. Now, this is a sector kind of wedged between that angle ACB. Let me fill in the letters. ACB. What is the segments? Now, they talk about chord AB. Where's chord AB? Over there. So you have the smaller segment there and then the larger segment at the bottom. That's the area that we need. How can we get that? If we can think of this big sector over there, we could get this area and add it to the area of the triangle. Then we'll be sorted. Okay. Now you can go to your formulae list. What is the area of a sector? Half r squared theta, or in our case ACB. Oh no, here's the paper. So we want the area of the sector. That would be half r squared times basically the reflex angle ACB. What's a reflex angle? It's an angle between 180 and 270 degrees. Right? No, between 180 and 360 degrees, sorry. Okay, doesn't matter right now. I'm just trying to find a way to write it down. What is the radius? Remember, square root 29. Now, how big is reflex angle ACB? Now, remember, that was what? 2.38. So this would be 2 pi, or 360 degrees, minus that 2.38. Okay, so I multiply by that. Okay, if you put that in your calculator, you'll end up getting 56.596. I'm just sticking to 3 decimal places. In the end, we can round as needed. Okay, but we're not done. Now we need the area of triangle ACB, which would be half base times height. We have the base of that one, remember. That's 5, so the whole base is 10. But what about the height? Where's the height? There. You can easily spot that. C is 7, -4, and whatever point that is would be on line y is equals -2. So to get from -2 to -4, how far is it? 2. So the height is 2. So it's simply half times 10 times 2. That's a half of 20, which is 10. So we get the area of the large segment as your answer from the previous one, 56.596 plus 10, which ends up being let's see, obviously 66.596, but they didn't specify rounding here. But at the beginning of these papers, they say round to 3 significant figures. So I'm gonna write 66.6. So that's the area of the large segment. Okay, moving on to question 9. This question has 4 parts, and they're all based on chapters 7 and 9, so it's differentiation and integration. So they give us the second derivative of y, and it is given that the curve has a stationary point at -2, 19, and we need to find the first derivative. Now, how can we do that? Well, to go from y to dy dx, you need to obviously differentiate, and then from dy dx to the second derivative, you also need to differentiate. Now we have the second derivative only. How can we move from the second derivative to the first derivative? We need to integrate. Even if we want to go from that first derivative to the original, we also need to integrate. So let's start by taking the indefinite integral of that second derivative. I'm taking the -24 to the outside. So that's basically x to the -3. Using your power integral rule, we'll have x to the -2 over -2, and we need to add a constant. What is -24 divided by -2? That's 12. So we have that, but we need to find a full expression for dy dx. We can't leave that c in there. How can we do that? Well, we know this curve has a stationary point. So if I equate that first derivative to 0, that's where it will have a stationary point. So c would end up being -12x to the -2, but we know where the stationary point is. It's at -2, 19. So x is equals to -2 over there. So I can substitute x is -2. So c will be this. So you can substitute that in your calculator. You'll get c is -3. So the full expression for dy dx is this. Okay. Now we need to find the x coordinate of the other stationary point on the curve and determine the nature of the stationary point, as in, is it a maximum or is it a minimum? Okay, well, how do we find stationary point? You need to take the first derivative and equate it to 0. We'll have 12 over x squared is equals to 3. Let's make use of our space here. Let me flip both sides. So x squared is 1 over 3 times 12, which is 4. To get x, you can do plus or minus square root 4, so plus or minus 2. Now, which one is the other stationary point? We already have the one for -2. So the other stationary point is at x is equals to +2. Okay. Now we need the nature of the stationary point. How do you determine the nature of it? You need the second derivative. We already have it from the beginning already. Now you just substitute that x into there. So you want the second derivative evaluated at x is equals to 2. So minus 24 over 2 cubed minus 24 over 8, which is negative 3. If it's negative, that means it is a maximum point. So if it's a negative, it's a maximum. It's positive, it's a minimum. Okay, that's for the second derivative. Okay, C. Now we need to find the equation of the curve. As in, we need the original y. Now, like earlier, I said to go from dy dx to y, we need to integrate again. So dy dx we found is 12 over x squared minus 3. So I just need to integrate that. Okay, we can split it up. Between the minus. Okay. We'll end up having 12 to the x negative 1 over negative 1 minus 3x plus, let's call this d. Okay, so this is negative 12 but we need to find that d. How can we do that? Well, we have a point on this curve, negative 2 and 19. Simply substitute that in there. What will happen then? I'll say 19 now we only have an equation with d. If you rearrange that, you'll find d is 7. Okay, so y is negative 12, x to the negative 1 minus 3x plus 7. Okay, the last part, question 9. Find the equation of the normal to the curve at the point where dy dx is negative 9 over 4 and x is positive. And we need to express it in that standard form. Now, what do we know? We know about tangents to a curve. Okay. And what is a normal to a curve? It's a perpendicular line to that tangent. Okay. Now, we are given the gradient of the tangent, because that's given by first derivatives. It's minus 9 over 4. That means for the normal, the gradient would be 4 over 9. Flip and change the sign. So y is 4 over 9x plus c. Okay, now we are just left with finding C. How can we do that? Let's see. We need a point to substitute in, but we don't have a point of where this normal happens. We can figure out where it happens because we have dy dx is negative 9/4, so we need to use that again. I can take that and equate it to the actual dy dx, which is 12/x² minus 3. We found that in part A. Now we can just rearrange this. 12/x² is negative 3 plus no, I'm taking it from the other side. It's 3. Here we go. 12/x² would end up being 3/4. X² over 12 is 4/3 then, so x² is 16 if I multiply by 12. So x can either be positive or negative square root 16, which is just 4, but we want x is positive, so x is just positive 4. Now we need a full point. So over there, I know now that what was our y, by the way? Okay, no, I just realized I drew a parabola over here, but this is not necessarily a parabola. That's just for explanation's sake. So we have 4, but what about y? How can we find that? Well, we can plug it into we can substitute x is equals to 4 in whatever y is. Remember, y is this, because it happens on that curve. So we'll have that. Okay, you put that in your calculator, you'll end up getting negative 8. Now we can substitute the point for negative 8 in the incomplete line. You will have negative 8 is 4/9 times 4 plus c. So if you solve that, c ends up being negative 88/9. I'm running out of space again. Okay, so we have y is 4/9x minus 88/9. We want it in that form, so we want to equate it to 0. Let's say now simply multiply by 9. You'll have 9y minus 4x plus 88 is 0. Okay, but they want x to be first, so we can say minus 4x, it's 9y plus 88 is 0, or it can even become 4x minus 9y minus 88 is 0 if you divide by a negative 1. Okay, we're almost at the end. So let's look at question 10. This is on chapter 6, series. The first, second, and third terms of an arithmetic progression are 4k, k squared, and 8k respectively, where k is a non-zero constant, and we need to find the value of k. Okay, an arithmetic progression or sequence has a common difference. So if I have term 1, term 2, term 3, if I take term 2 minus term 1, I will get d, the common difference, and term 3 minus term 2, I would get d. So term 2 minus term 1 is equals to term 3 minus term 2. So I could do, so we have 4k, k squared, and 8k. So k squared minus 4k should be equals to 8k minus k squared. Okay, let me bring all the k's, everything to the left basically. K squared plus k squared minus 4k minus 8k. 2k squared minus 12k. Now we can factorize this. I can take out the 2 and a k. I'll have left k minus 6. So 2k is 0. K minus 6 is 0. So k is 0 or k is 6. But technically they said k is non-zero, so you reject that. So k is 6 only. Okay. 2. Find the sum of the first 20 terms of the sequence. Okay. Now, this is an arithmetic series, basically. In your formulae list for an arithmetic series, you have these two formulas. The first one is for if you have the last term of the sequence. We don't have that, so we rather use this second format. Okay, so we have Sn is half of n to a plus n minus 1 times d. Okay, what is our n? We're gonna sum until 20. Do we have a? No, we need to find that, but we do. And do we have d? Not technically, but we know d is term 2 minus term 1 or term 3 minus term 2, which is either you could use k squared minus 4k, 8k minus k squared. Let's say, so d is k squared minus 4k, and we know k is 6 now. So 36 minus 24 is 12. Okay. A, what is A? A is the first term. We know the first term is 4k. So 4 times 4 is, oh no, not 4 times 4. 4 times 6. K is 6. I'm thinking of another question. 24. Okay, now simply, what is S? 20. Okay. 2 times 24 plus n minus 1, which is 20 minus 1, 19 times d, which is 12. So I have 10 times 48 plus 228. So the sum until 20 is 2760. There we go. This is easy stuff. B. Okay. At B, they're gonna get a bit, what can I say, out of hand with a bunch of square roots. We have the fourth and sixth terms of a geometric sequence. The common ratio of the progression is positive. We need to find the sum to infinity of the progression and give our answer in a predetermined form. Okay, let's imagine, so in this sequence, term 4 is 36, term 5, we don't know, term 6 is 6, coincidentally. This term 5, we don't know, let's call it x. Okay. To get the sum to infinity in the end, it's also in your formulae list over there, you need a and r. Okay, for this, we don't have a or r. Okay. R is the ratio. So R would be, in this case, x divided by 36 or 6 divided by x. But we don't have that x, but we have this little equation now. So let's use that. So I can cross multiply. X squared is 6 times 36. X squared is 216. So x is the square root of that, because we have a positive common ratio. I don't want the negative one. Okay, so x, if you put square root 216 in your calculator, it's 6 square root 6. So r is x over 36, so it's 6 square root 6 over 36. Put that in your calculator. That would become square root 6 over 6. Now, what about a? We need a. Okay, the one that will go at the top. Well, this is a geometric series. Yeah, technically. But a geometric sequence also for each term. Now we have the general formula for each term is this. Let's use that. So, I'm going to the tree graphs again. So un, or we technically sometimes call it Tn, the general term is ARN minus 1. Now we say we have the fourth term, and we have R now, square root 6 of, and 4 minus 1, n minus 1. What is the fourth term equal to? It's 36, so I can say 36 is equals to a, that to the power of 3. Okay, you can do a bunch of rearranging over there. You'll end up having a is 36 squared over square root 6, and that's basically 1296 over square root 6. So now we can simply find a over 1 minus r. Now the tricky part is going to be having to get it into that a over square root b minus c, where a, b, and c are integers. So minus r. Okay. I can get common denominator at the bottom. That is x minus square root 6 over 6. Okay. Flip, do, keep, change division to multiplication. So 1296 over, we flip the bottom fraction. Like that. 1296 times 6 is 7776. And at the bottom we have square root 6 times 6 minus square root 6. Okay. Multiply. No, don't multiply the square root 6 in. Factor out. So we have that. What is 6 equal to? Square root 6 times square root 6. Okay. I factor out the square root 6 there. I'll have that. And square root 6 times square root 6 is 6. Okay, there's probably more than one way to do that. So I have 7776 over 6 times square root 6 minus 1. Okay. Am I still on the right track? Always need to make sure. Yeah. Okay. And now 7776 divided by 6 is 1296, and we still have left square root 6 minus 1. Do we have it in their format? Yes. A number, a root, minus a number. So A is 1296, B is 6, and C is 1. Okay. Okay, question 11. Question 11, I think, is the easiest question, the paper. So try to get all the marks here. Okay, so this is just completing the square. We can write this as maybe this, or you could use any other method. In the end, they just want x plus 2 squared minus 2. Okay. Now we need to find the inverse of f. We have two functions, f and g. We need the inverse of f, which is a quadratic. And it is coincidentally, well, not really, the same expression that they gave over there. So you can simply use your answer from A. Okay, we need the inverse. I usually write x, y, then I swap them. Okay, I try to get y on the left. Okay, we need, for now, plus or minus. So y is plus or minus 2, but we can't have both. Otherwise, the inverse won't be 1 to 1. We need it to be 1 to 1. Now, how do we know? Do we need to take the plus or the minus? If you look at the original if, its domain was x is less than or equal to negative 2. That domain becomes the range of the inverse. So you want everything that's y is less than or equal to negative 2. So everything below negative 2. Now how can I get, if I make this positive, I'll be adding a positive to a negative, making this above negative 2. If I wanted to be below negative 2, I would have to go more into the negative, if you want to think about it like that. So we need the negative root. So if inverse is this, there we go. Question I, we need GF inverse. Now you can either find GF first, as in substitute F into G, take that result and find the inverse, or you can use this fact. GF inverse is F inverse G inverse X. So take G inverse and substitute it into F inverse. Now we need G inverse. G is negative x minus 4. So if I find the inverse, I have x plus 4 is negative y. So y is in any way just negative x minus 4. So G inverse is the same as G, actually. So I just need to substitute that into F inverse, which is from the previous question, minus negative x minus 4 plus 2 minus 2. Okay, minus 4 plus 2 is negative x. Let's just write it nicely. Minus 2. There we go. That's the end of the paper. Thank you for watching.